A modern plastics manufacturing floor is a blur of continuous, high-speed motion, churning out material at an intense rate. But when that motion stops completely, the financial impact is immediate. In this industry, mechanical stillness equals rapid financial loss. Every idle second burns through capital, converting a highly efficient production line into a severe financial liability. The primary cause of this costly paralysis is a routine, strictly scheduled maintenance event, the screw pull. A screw pull is the process of physically extracting the massive central rotating screw from the machine barrel for inspection and cleaning. Facilities must intentionally halt their own production, sacrificing hours of output, simply to accommodate the heavy labor requirements of their maintenance protocols. Looking inside the machinery reveals the physical reality of this delay. Thick, degraded polymer creeps into the tight, deep flights of the metal screw. Over thousands of processing cycles, residual plastic and carbon physically bake into these narrow spaces. The material hardens into a dense layer that behaves like industrial cement. Extracting this baked-on residue requires hours of intense manual labor. Maintenance teams must rely on hand scrapers, chisels, and secondary chemical solvents to force the metal clean again. Workers handle these heavy metal components while they are still coated in partially molten, high-temperature residues, creating severe safety risks on the factory floor. For decades, the industry has relied on primitive brute force to solve a complex issue of physical chemistry. Operators historically attempted to soften this buildup by pouring chemical purging compounds into the machinery prior to a shutdown. This diagram contrasts two maintenance approaches. On the right, traditional chemical purging uses heat-activated additives to trigger gas expansion and a foaming action. This reaction introduces hazards, releasing volatile fumes into the workspace and risking embedded chemical residues in the equipment. A specialized compound called PEKUTHERM takes a different approach. PEKUTHERM is a highly engineered mechanical screw pull aid. It abandons chemical reactions entirely, utilizing mechanical, thermoelastic physics to clean the system. Focusing on the left side of the diagram, the mechanical purge forms a solid plug that physically scrubs the metal flights, leaving zero chemical byproducts behind. Physically scrubbing the internal machinery with a solid mass yields a safer and highly predictable extraction, completely bypassing the risks of volatile chemical reactions. When this exact material enters a hot machine, it softens without melting. It rapidly transitions into a highly viscous, self-adhering mass. Following the yellow arrows, the thermoelastic mass acts as a mechanical bulldozer, forcefully pushing residual resin and carbon forward. It swallows color contamination and carbon fragments, encapsulating the waste inside itself, while strictly refusing to bond with the heated metal machinery. This creates a unified, solid purge plug that traverses the entire length of the internal system as a single, unbroken entity. By physically changing the entire state of the internal waste from a stubborn, baked-on residue into a solid, cohesive block, the entire process of mechanical extraction completely changes. When maintenance teams pull the screw, the heavy hardware slides effortlessly out of the machine barrel, revealing a gleaming, completely clean metallic surface. The thermoelastic mass leaves behind only a thin, transparent film on the metal. Operators describe this residue as looking and acting like clear cellophane. This thin layer can simply be peeled away by hand, completely eliminating the need for metal scrapers and chisels. Removing that single physical barrier cuts labor requirements drastically. A grueling, multi-hour cleaning session becomes a rapid, visual-only inspection event. This dual-use capability simplifies overall plant inventory, as one product manages both daily production purging and specialized heavy-duty maintenance pulls. The core financial value of this process is the total elimination of secondary manual labor from the scheduled maintenance window. This method scales reliably across the differing demands of major plastics manufacturing processes. This formulation guide details the performance in extrusion operations. It demonstrates that the purge functions across all machine sizes to significantly reduce the total duration of planned maintenance shutdowns. In complex injection molding environments, as shown in this chart outlining machine scales from 80 ton up to 150 ton and larger, it clears out rapid color transitions and prepares the hardware for instant inspection. The system provides extreme thermal flexibility. It works seamlessly in ultra-low 175-degree Fahrenheit rubber operations, as well as high-temperature polymer runs exceeding 750 degrees. Every minute a machine sits open on the floor, the facility loses revenue. Adopting a mechanical pull aid allows modern manufacturers to turn dead downtime back into active, profitable production.